Let's see a new type of random variables. Till now we have seen one class of random variables which are called as discrete random variables, and in those discrete random variables we are able to discuss about what is the probability that a random variable can take exactly a particular value. For example, while while rolling two dice, you can talk about what is the probability that the sum of two dice is going to be exactly 3 if x is a random variable, discrete random variable denoting the sum of two dice. When I roll them, then what is the probability that the sum happens to be exactly 3? For this we are able to derive the probability. What are the events that will be covered in this? One is 1 2, other is 2 1, and the probability of this one is 1 by 36 and probability of this one is 1 by 36. When I add them up, it is going to be 2 by 36. Therefore the main difference between a discrete random variable and a continuous random variable is, in discrete random variable we'll have some countable number of values which our random variable x can take on. Are you getting this? We'll have a countable set from which our x can take on. For example, in this one our x can take on values from 2 3 4 so on 12. Countable set, right? We'll have some countable values, and then for these elements in this set we'll have some particular probability which is greater than 0. Got it? But then there will be certain kind of experiments which cannot be solved or which cannot be expressed using discrete random variables, and such experiments, in such experiments we use continuous random variables. To give you an example, let's say there is an archaeological department, and in their diggings they found out that an object. Let us say they found out a pot, and now based on the properties or based on the characteristics of the pot, the chemistry or whatever, based on the properties of the pot, archaeologist has to determine when is this pot exactly made. Now in such an experiment, if you assume that capital X is a random variable which will give us the age of the pot, then this particular value x will not be able to take exact point in the time. Are you getting this? See, while digging up while if you found out an object, and you cannot, there is no way that you can say exact date on which it is made, but then what you can say is a period. Let us say they will say that this pot might have been made during 1852, maybe 1865, something like this. But then if you ask them what is the probability that it is made exactly in the year 1850, they will not be able to say it. But for a range they will be able to say it, which means if our random variable is not going to take discrete values, if it is going to take a continuous range which is uncountable, then in that case our random variable has to be continuous random variable. Got it? So what is the difference between a discrete random variable and continuous random variable? In discrete random variable our random variable will be able to take up some points in a countable set, but in continuous random variable our random variable will not be able to take any point, it will be able to take a range, right? We talk about a range, and in fact the number of values that our random variable can take is uncountable. In discrete it is countable, and in continuous it is uncountable. If you want one more example, maybe if you are conducting an experiment to find out what could be the lifetime of a car, then you will not be able to say that it is exactly 2 years or it is exactly 3 years, but then the probability that it is going to be between 2 and 3, you can be able to say it, right? So coming to these continuous random variables, we will not be exactly interested in a point, we will be interested in a range, right? Therefore if you have a period of time, right, so if you are trying to find out the probability that the lifetime of a car is this point, you will get it as 0. But then if you try to find out the probability that the lifetime of a car is from here to here, yes, you will be able to find out using the continuous random variables. The same as that archaeological department and our object, the same experiment. Likewise, we can perform many experiments in which we will not be able to find out the probability that a random variable will be able to take a point, but then we will be able to find out the probability that will be able to take the period. Now just see the definition. Let capital X is a continuous random variable if the set of possible values it could take is uncountable, like that. Uncountable means if you are trying to find out when an object is made, then the set of values that our random variable can take is minus infinity to present day, isn't it? Whatever today is. If you found out an object today and if you are trying to guess what is the period that it is made, it can be anywhere from minus infinity to present day, isn't it? And how many elements are there? Uncountable, right? Just in a set 0, 1 you have uncountable number of numbers, right? So about countable and uncountable, you please watch TOC videos with that. There we have exactly discussed about it. Okay, so first thing is, if you have to have a continuous random variable, then the number of values it should take is going to be uncountable. In case if it is going to be countable, then it is discrete. Okay, and the second one is, and there exists a non-negative function called f of x, called the probability density function, having the property that for any set capital B of real numbers, probability that our random variable belongs to that set is given by integration of that particular function. So what is the meaning of it is, if you are defining a continuous random variable, then you should also define a function, right? And the function should be like this. Let us say this is x, and our function, let us say a function is defined like this. And now if you are interested in finding out what is the probability that our random variable has taken a value between a and b, then you have to find out what is the area under that curve between the points a and b, right? This particular area. And this particular area is going to give us the probability with which our random variable x will take any value between a and b. This is f of x. Alright. So what I mean by this is, if you are interested in finding out the probability that a random variable will take certain value between a range, then you are supposed to have a function for every continuous random variable. A function should be defined that is called as probability density function. And once you know the probability density function, the probability that our random variable, that our continuous random variable for which this function is defined, can take the value between a and b is equal to the area under this curve. And we know that the area under this curve is given by integration of the curve, right? So later in integration we shall again see how to integrate, what is definite integrals and how to integrate it. But I assume that you know the basics of this integration, so I am directly writing it here. Here we are not going to have complex functions, they will be very simple. You need not again go to the integration topic and see it. You can directly do them, they will be very simple. I'll just show you how we can use this function f of x. Let us say we have defined a random variable capital X, and then a function f of x is defined for that. Now if you are interested in finding out the probability that our random variable will take a value from a to b, right, probability that our random variable capital X can take a value between a and b is given by integral a to b f of x dx, where f of x is probability density function. Are you getting this? The probability that our random variable capital X can take on a value between small a and small b. This range is nothing but area under the curve f of x. And how do we get the area under the curve? It is nothing but integration between these two values, right? Now let us say you are interested in finding out the probability that our random variable will take a value less than or equal to a. Then how can you find out? So you have to find out the probability, which is nothing but the area under this curve, less than or equal to a, which means everything less than or equal to a. That is nothing but area under the curve f of x from the point minus infinity to a. Got it? Now interestingly, since it is the area under a curve, what happens is, if you try to find out the exact probability that a continuous random variable will take a value a, some particular value a, is nothing but area under the curve between this range, and the range is from a to a, isn't it? Which means you have to integrate like this, from a to a f of x dx, right? So what does it mean? You have a curve like this, and now from a to a is nothing but this one. So you are interested in finding out the area of this part. Now if you see this, it is nothing but a kind of rectangle, and for a rectangle the area is nothing but breadth into height, and height we know it, right? It is nothing but f of a, but if you see the breadth, it is nothing but 0. Therefore area is 0. So what does it mean? Using this formula, generally this is the formula which we use for any continuous random variable. If you try to find out the probability that a random variable is going to take exactly a particular point, it is always going to be 0. But in case of discrete random variables, the probability that a random variable takes on a value might sometimes be non-zero. For example, in case of rolling two dice, what is the probability that the sum of the two dice is going to be 3? It is actually 2 by 36, right? So like that, we know in some of the problems in discrete random variables, we have the positive probability that a random variable can take a point, but in continuous random variable it is always going to be 0 for a point. And also you can understand one thing, the total probability, the total area under the curve is always going to be 1. That is what we have already seen, right? So for any random variable, the total probability has to be 1, which means if you try to find out minus infinity to infinity f of x dx, this should always be equal to 1. So these are the properties any random variable, any continuous random variable should satisfy. And then based on the exact function f of x, depending on what f of x is, we can again classify the random variables into various types. Now we shall see what are the different types of continuous random variables. Till now whatever we have seen is what are the different types of discrete random variables which are exactly in GATE syllabus. I have discussed only few of them which are exactly required for GATE syllabus. Not everything is required. So now we shall see what are the continuous random variables which are in GATE syllabus only. Even though we have a lot of continuous random variables, I'll be taking only the part which is present in the GATE syllabus. If you are interested in knowing everything, you can read various books. Almost every textbook on probability will have them. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.